Algebra 1, Sensei Learning System, Lesson number 5. These are all perfect squares, and we're taking the square roots of them. So the square root of a perfect square of 1 is 1, the square root of a perfect square of 4 is 2, the square root of a perfect square of 9 is 3, the perfect square of 16 is 4, and so on. Now, we want to find out how do you estimate a number when it's not a perfect square. So over here we have a square root of 2. 2 is not a perfect square. But if you look on this chart, 2 would fall between the square root of 1 and the square root of 4, and it would be closer to 1. That means that the answer for 2 would fall somewhere between 1 and 2, and the answer would be closer to 1. So I would estimate that at about a 1.2, and the 0.2 puts it close to 1. Now the square root of 3 is between the square root of 1 and the square root of 4, but the square root of 3 is closer to 4, so it would be between 1 and 2, but closer to the 2. So I would estimate that to be about 1.8, and the 8 places the estimate closer to 2. The square root of 5. The square root of 5 is between the square root of 4 and 9. That means that the solution is between 2 and 3. Since the square root of 5 is closer to the 4, I'll make it 2, and let's say 0.2, which makes this closer to the 2 than the 3. Now these estimates here don't have to be right, but as far as the decimals, just have to be a little close. The square root of 8. The square root of 8 is closer, it's between square root of 4 and square root of 9, and it's closer to the 9. That means that it'll be between 2 and 3, but closer to the 3. So let's say 2.8. That brings it closer to the 3. The square root of 20 is between the square root of 16 and 25. It's just about in between the square root of 16 and the square root of 25. So the answer should be just about in the middle of 4 and 5. So I'm going to say 4.5, which kind of puts it right in the middle. The square root of 50 is between the square root of 49 and 64. So the answer would be between 7 and 8. Since the square root of 50 is closer to the 49, I'll make the answer closer to the 7. So this will be approximately, say 7.2. And these are all approximations, so no equal signs. Okay, let's deal with the square root of 80. Square root of 80 is between the square root of 64 and the square root of 81. It's much closer to the 81 than it is to 64. That means the answer would be between 8 and 9, and much closer to the 9. So I would say 8. Let's say 8, or I could have made that a little higher, maybe 0.9. Now, square root of 90 is between the square root of 81 and the square root of 100. That means the answer is between 9 and 10. This is almost evenly between 81 and 100, so I'll take a number evenly between 9 and 10. Let's say approximately 9.5. Now, let's deal with simplifying by finding perfect roots. Perfect roots have pairs. 4 can be found by getting a 2 times 2. A 9 is the perfect pair of 3. 25 is the perfect pair for the pair of 5s, and 64 8 times 8. So if we can find these pairs, what we really found are these perfect squares. So 12. Let's see if we can find any perfect squares by factoring this. First, I'll divide it by 2 and make that 2 times 6, and then I'll divide 6 into 2 times 3. Now all these branches are prime numbers, 2, 2, and 3, and we see that we have a pair here. So I'm going to circle that pair, and I'm actually circling a 4. So what we have here is a 4, and left over is a 3. So I'll put the perfect square, so what's circled I put up front here, and what's left over here I'll put in back. And so we can take the square root of the 4, and that becomes a 2. And so instead of square root of 4 times 3, it becomes a regular 2 times the square root of 3. And we don't have to write the multiplication in here. We can just say 2 square root of 3, which means 2 times square root of 3. Let's see if we can find any pairs inside 18, which would be perfect squares. So let's start with 18, and I'll make that 2 times 9, and then 9 is 3 times 3. Okay, these are all my prime numbers, okay? And I found I have a pair here. So that's my pair. So that's going to be a perfect square. So we'll make 18. The pair will go up front, that's the 9, times all the numbers that are left over, which are the 2. And so now we can take the square root of 9, which is 3, multiply it with the square root of 2. And now it's simplified. Or just 3 square root of 2. 24. 24, I'll factor that into 2 times 12. And the 12 will factor that into 2 times 6. And 6 will factor that into 2 times 3. And now we can see all our primes, 2, 2, 2, and 3. That 24 is made of. I'm going to circle a pair here, okay, and that pair will be my perfect root right there. So I'll put the pair up front, the 2 times 2, which is 4. These up front. Everything else, the 2 and the 3, will go in the back as a 6. And so I have my perfect square up front. So let's take the square root of 4. That becomes a 2, and what's left is multiplying times the square root of 6. Next, 54. Square root of 54. So let's start off by dividing by 2, and that'll give me a 27. And I can divide this by 3, and that'll be 3 times 9, and I can divide 9 by 3, and 3 times 3. So here are all my primes right here, 2, 3, 3, and 3. I have a pair here, so I'll circle it. And these two are not pairs, so I'll put the pairs up front here. That'll be 9 times what's left over, which is a 2 and a 3, which is 6. And now I'll take the square root of the 9, and that'll give me 3, and times the square root of 6. Alright, 40. Let's divide that by 2, and we'll get 20. Divide it by 2 again. We'll get 2 times 10. Divide that by 2 again, we get 2 times 5. That's about as far as we can go. And we'll find our pairs. Okay, there's a pair right there, the 2's. And what we get, that makes a 4. And the 2 and the 5 is left over, so that makes a 10. And we'll take the square root of the 4 here, and we'll get 2 and the square root of 10. Okay, to 150. 150, we'll divide that by 2, and that'll be 2 times 75. And then I'll divide that by 3. That'll be 3 times 25. And then I'll divide this by 5 and get 5 times 5. Okay, so I look for pairs, and here's a pair right here, those 5's. So this means that the pair, 5's, become a 25, times everything that's left over, which is a 2 and a 3. That'll be a 6. So I take the square root of 25 and get 5 times the square root of 6. Now, let's rationalize bases. That means get roots out of the base. How do we get the root out of the base is that we use another root. So the square root of 3, multiply it with another square root of 3. But whatever you multiply by the bottom, you must also multiply by the numerator. So there needs to be another square root of 3 in the numerator. That makes this equivalent to 1, and the problem has not changed essentially. Okay, so multiplying these, 5 times the square root of 3 gives us 5 times the square root of 3. The square root of 3 times the square root of 3 multiplies and gives me the square root of 9. The square root of 9 becomes, I'll go this way. The square root of 9 becomes a 3 without a root. And 5 square root of 3 is left in the numerator. Okay, let's go to number 2. Okay, we're going to multiply this by the square root of 7 on the bottom and also square root of 7 on top. This will give us 4 times the square root of 7, and square root of 7 times square root of 7 is square root of 49. 4 times the square root of 7 does not change, but the square root of 49 changes into a 7. Here we have a 6 over square root of 3, so we'll multiply this by the square root of 3, and also the top by the square root of 3. So 6 times the square root of 3 is going to be 6 times square root of 3. Square root of 3 times square root of 3 is going to be square root of 9. 6 times the square root of 3 does not change, but the square root of 9 becomes a 3. And I can now divide 6 divided by 3, which becomes a 2, times the square root of 3. Okay, here I have the square root of 7 in the denominator, so we're going to multiply by another square root of 7, and whatever you multiply on the bottom, we'll also multiply it on top. So what we get on top is 21 times the square root of 7. On the bottom, square root of 7 times square root of 7 will be the square root of 49. 21 times the square root of 7 remains 21 times the square root of 7, while the square root of 49 becomes a 7. Here I can divide 27 into 21, it will go in there 3 times the square root of 7. Here I have a square root of 6 I want to get rid of in the denominator, so I'll multiply by another square root of 6, and when you multiply on top, you multiply on the bottom, you multiply on top. So I have a square root of 5 times square root of 6, that's going to be the square root of 30. The square root of 6 times square root of 6 is going to be the square root of 36. The square root of 36 is a perfect square, so we'll get 6. The square root of 30 is not on the list of perfect squares, so it stays square root of 30. Here we have the square root of 3 over square root of 5. I'm going to multiply this by the square root of 5 on the denominator and square root of 5 in the numerator. Square root of 3 times square root of 5 is the square root of 15. The square root of 5 times square root of 5 is the square root of 25. The square root of 25, because it's a perfect square, will be 5. 15 is not a perfect square, so that remains the square root of 15.